Now let's look at another blend mode, multiply. Multiply, like the name implies, multiplies the color channels. So here we have the same destination and source again, and you can see that's exactly what multiply does. 0.5 times 0 is 0, and 0.5 times 1 is 1. Or with a more interesting color, 0.5 times 0.25 is 0.125, 0.5 times 0.5 is 0.25, and 0.5 times 0.75 is 0.375. And that explains why multiply makes things darker. Since your numbers are usually lower than 1, when you multiply them together, they get smaller, which means your result tends towards black, which means it gets darker. Let's look at another blend mode because I'm going to use it as an example later. Addition, also known as linear dodge. Like the name says, it just adds the channels together. So here, 0.5 plus 0.25 is 0.75, 0.5 plus 0.5 is 1.0, and 0.5 plus 0.75 is 1.25, but you can't have numbers larger than 1, so it just turns into 1. And that explains why addition makes things brighter, because, numbers get bigger, tends towards white, so it means it gets brighter. Now let's look at this picture with some shading and lighting on it. So we have some shading here at the top left, which you can see kind of spilled outside of the character. We're going to get to why that happened later. And we have some glow around the whiskers and around the rock there. If we look at the arrangement of these layers, it's kind of like you would expect. You got the shading on top of the lines in the flats layer using multiply, and you have the shine as an add layer or linear dodge. Now let's look at how this is composited again. We start with an empty destination. We go through the layer stack from the bottom to the top. Our background becomes the source. We composite that onto the destination. Next layer, the flats layer. Once again, we just composite that onto the destination. In normal mode, you now know how this works. Next layer, the lines layer, just like before. And now the multiply layer. And now you can see the multiply layer multiplies everything that is in the destination up to now. So it multiplies with the result of the background, the flats layer and the lines layer having been composited. So everything on the destination gets darker. Now we move on to the next layer, the shine layer, same idea. It composites with everything that's on the destination, so it makes everything brighter. We move on to the next layer. There is no next layer, so we're done compositing the image, and this is the final result. Okay, now let's assume we want to tidy up this image because we want to add a background to it. So let's make a folder and put our layers in there. We'll take our layers like before, and we're going to put these ones, all the ones except for the background, into a folder. And when we do that, it looks different. Before, the shading was dark and the glow was glowy. And after we put it into the folder, the shading up there turned weirdly purple, and the glow stopped glowing, it turned orange. Why did that happen? The reason is we didn't really put it into a folder because that's not a folder, that's a layer group. To explain why this weird result happens, let's look at what's going on here by compositing this image. And now this is where it starts getting interesting here. Once again, we start at the bottom of our layer stack, our destination is empty, and we composite the source onto the destination. So far, just like before, it just turns gray. Now we move on to the next layer. And the next layer is not the flats layer inside the layer group. The next layer is the layer group itself. But how do we composite the layer group onto the destination? We have to composite the layer group itself first. So what the program does is it puts the destination away and starts with a new destination inside of this layer group. So it starts with an empty destination again, and once again goes from the bottom to the top. So our flats layer becomes our source, and we composite the flats layer onto our destination. Next layer, the lines layer, put that onto the destination. Now we move on to the shade layer, and this is where it starts getting different. If we look at how it worked before, when we didn't have the layer group, our destination looked like this, where it had a gray background. But now, our destination has a transparent background. And that's why it's different, because now when we composite the source onto the destination, it doesn't multiply with the gray. Instead, it just multiplies with the transparency, and we get a different result. Same with the shine layer here. Instead of adding to the gray, it now adds to the transparency, and we get orange. Now we move on to the next layer. Since there's no next layer inside this group, we're done compositing it, and we move outside of it again. So that means our group becomes our source, and our old destination gets recalled. And now we can actually composite this group onto the destination. It basically got merged into a single layer and now gets composited onto the destination all at once. Since the layer group is in normal mode, it gets composited onto the destination like a normal layer. And we get this result. So that's how layer groups work. They fundamentally change how the image is composited, and they make the program start with a transparent destination again, which can be very useful, which I'll be getting to later, or not, like in this case where it changes the result unintentionally. So understanding this is paramount in understanding how a drawing program works. Okay, but as said, like the shade layer multiplies with transparency. How do you multiply transparency? Now, if we look at the opaque pixels, their color channels get multiplied and they get darker, so that makes sense. But what happens for the transparent pixels? What is their color? What gets multiplied here? Well, let's look at a different blend mode. Let's look at screen, which is the opposite of multiply. And you can see in the top left corner, between multiply and screen, that the result is the same, even though these blend modes are opposites. Now keep your eye on the top left corner. Let's look at overlay. That's the same result. What about color burn? Still the same. What about the opposite of that? Color dodge. Still the same result. Saturation? Still the same result. But what is it doing? What are all these blend modes doing? And you can see what they're doing if I change the blend mode to normal, because that's what they're doing. A lot of blend modes, when you apply them over transparent pixels, don't actually give you what they say on the tin. They instead just give you normal blending. But why? How is this useful? Well, I would say this is completely useless. This is behavior that all drawing programs share, because that is just how blend modes are defined mathematically. But in art, it probably just means you made a mistake. You usually don't want this. And the correct way to apply these blend modes to transparency is to not do it, because it doesn't give you the result you want. Okay, but how do you not? Surely the solution is not to manually go through every pixel and make sure it's not transparent. Of course not.